Welcome to Magic Boy fans.
Welcome back to the deep dive. Okay, forget the high-tech labs and, those glossy corporate case studies for just a minute. Today, we're deep diving into a really spectacular story of engineering success, and it's one that completely bypasses the traditional idea of expertise. It kind of proves that sometimes the most sophisticated solutions are actually hidden right in plain sight. Our source material today is, well, it's rich and pretty unusual. We're looking at excerpts from The Shepherd's Turban and the Watawala Rail, specifically W.N. Wirathunga's narrative poem, The Ballad of the Shepherd's Turban. Our mission here is to go beyond the poetry, really, and unearth the precise ingenious engineering principle that saved this massive infrastructure project. And it all came down to a piece of visual, local wisdom.
Yeah, and we need to set the scene properly. We're talking 19th century Watawala. British engineers are trying to push this crucial rail line through an absolutely brutal landscape. Think jagged mountain crests. This isn't just a construction story. It's really about a cognitive clash. You've got this global industrial power, steel and steam, as the poem puts it, backed by the best mathematical minds of the time. And they're running headlong into a geological reality, an environment that just refused to play by their textbook rules.
Okay, let's start right there. At that point of failure, the engineers, they arrived full of confidence, right? The ballad says they had plans in hand. They believed their advanced methods could basically conquer anything. But the Watawala mountain range, well, the source material says it mocked their grand command.
It really did.
So what was the core issue? Was it just the steepness?
Primarily, yes, the gradient. For 19th century steam railways, especially hauling heavy freight, there was a hard limit. You couldn't go much steeper than maybe 1 in 44, that's about 2.2% gradient, before you lost traction, or worse.
Right, catastrophic failure.
Exactly, and this mountain, it presented slopes way, way steeper than that limit, far in excess.
So just impossible slopes for the tech they had.
Pretty much. They were up against a slope so sheer, so relentless, any straight line approach was out. Even with huge cuts or tunnels, the engineers, they'd run all the numbers, drawn every map they could think of, and the conclusion was just unanimous. No engine dared to draw near. The line simply could not be laid.
But wait, wasn't their theoretical knowledge correct?
Well, yes and no. Their physics, their maths, that wasn't wrong. But it was incomplete for this specific context. They were operating inside a framework, a very Victorian mindset that really prioritized efficiency, directness, straight lines, conquering nature, essentially.
Oh, okay.
And this raises a really critical question about problem solving, doesn't it? Why didn't they immediately think of, say, winding or looping the track? I mean, the technology for switchbacks, even helixes, it did exist then.
So why not use it?
Well, the likely answer, thinking about the historical context, probably comes down to cultural and cognitive bias. They were trained to overcome obstacles directly, blast through the mountain, bridge the valley. They weren't really trained to harmonize with the terrain by, say, massively increasing the track length just to ease the gradient. That felt inefficient, maybe even weak to them.
So their equations stopped working because their mental model just hit a wall. They couldn't imagine that kind of radical compromise.
Exactly. It wasn't a physics failure as much as a failure of imagination, maybe rooted in a kind of institutional pride.
Fascinating. These world-renowned experts, defeated by a lump of rock they couldn't calculate their way around.
But that failure, it really sets the stage perfectly for the solution.
Right, because the ballad describes this pivotal moment. Through morning mist, a figure came, totally contrasting with the defeated engineers, just a humble shepherd unknown by name.
And that contrast is so powerful, isn't it? You picture the scene. Brass instruments, detailed blueprints spread out. And then this local guy, quiet, unassuming. What caught the engineer's attention, and what the poem really zooms in on, wasn't his clothes or anything, it was his headwear. A turban wound upon his brow.
The turban, okay.
Think about it. The engineers were stuck on their two-dimensional maps. The shepherd, maybe without even realizing it, was about to introduce them to the third dimension they desperately needed.
And the breakthrough itself. It sounds almost too simple. He didn't draw a diagram, didn't do any math. The ballad says he just bowed his head, then twisted tight. He used the folds of his own turban, manipulating them right there in front of everyone.
A physical demonstration, pure visual analogy.
Yeah, it wasn't about calculating grades or rock cuts anymore. It was about loops, turns, mimicking how the cloth naturally contoured. He was basically showing them, look, you're trying to fight the slope, you need to embrace it, make the path longer. His directive, according to the poem, was, your rails must loop where mists persist.
And that's the application of natural practice spatial knowledge, isn't it? Think about how a shepherd actually navigates that kind of terrain day in, day out. They instinctively find the path of least resistance, which is almost never straight.
Right. The easiest way up a hill is usually winding.
Exactly. And the turban itself, it's a functional item. It needs a precise, tight, upward spiral to stay secure on the head. It's a small-scale, load-bearing structure, in a way. He just instinctively applied that same structural geometry, that spiraling form, to the problem of getting a heavy train up a steep incline.
Okay, so let's get into the technical details now, because it wasn't just make some curves.
No, definitely not. The shepherd's advice translated into a very specific and actually quite complex infrastructure design.
Right. The basic problem was gaining too much height over too little horizontal distance. So the solution is you need more distance. If you, say, double the track length to climb the same 100 feet, you effectively have the gradient. Simple physics.
But they needed a massive increase in track length, crammed into a very confined mountainous space.
And that's where the specific construction comes in. 2 spirals around the mountain steep. That's the key phrase from the ballad, the double spiral. It wasn't just a simple zigzag or a single loop, which you do see in some mountain railways.
That double spiral, or you could call it a double helix loop, is absolutely critical here. See, if they'd just used one single continuous spiral going all the way around the mountain, the radius might have become too large, taking up too much space, or they wouldn't have gained height fast enough before hitting that gradient limit again.
Okay, so how does the double spiral fix that?
The genius of the double spiral is how it maximizes that horizontal travel, the track length, within the narrow confines of that specific terrain. You essentially have 2 tracks, one built over the other, like a 2-lane corkscrew winding up the mountain.
Ah, stacked on top of each other.
Precisely. And the source emphasizes this crucial kind of counterintuitive detail. The second beneath, a secret to keep. Now, that strongly implies it wasn't just 2 parallel tracks side by side. It suggests one track actually overlapping and circling underneath, or maybe inside the path of the track above it.
Wow. So using short tunnels or maybe major earthworks to actually stack the railway lines?
That's how it seems. This overlapping geometry, this stacking, meant they got double the effective track length, and therefore roughly half the gradient without needing double the mountain footprint. They traded height for distance, but with maximum density. A brilliant spatial solution.
Can you just imagine the engineers when they finally grasped that? Months of struggle, all their complex calculations with slide rules,
Yeah.
all suddenly superseded by this shepherd's visual metaphor using his turban.
Yeah, the ballad says they gazed, hearts in awe. They immediately recognized it. Wisdom hidden without a flaw.
They must have realized they'd been trying to force a flat, straight geometry onto a world that's inherently curved and vertical.
It was a huge philosophical shift for them, wasn't it?
Yeah.
A victory for applied local knowledge over abstract theory.
They had to fundamentally change their whole approach,
Yeah.
abandoning that conquer nature model for one of integration.
And that shift in perspective, that's really the core takeaway here, I think. If you connect this to the bigger picture of innovation, it just demonstrates so clearly that complex engineering often needs knowledge from outside the usual disciplinary silo.
Yeah.
The shepherd hadn't studied Euclidean geometry, but he had applied geometric principles his entire life, managing his clothes, his flock, finding paths. The engineers, being highly specialized, had maybe lost the ability to see those basic principles through the sheer complexity of their own tools and training.
So once they adopted this new turban blueprint, the work finally got moving again. The ballad describes the completion quite beautifully. With careful hands, the rails were laid through rock and stone, through sun and shade.
Mm-hmm.
And the scale of the achievement is really emphasized by its lasting legacy.
Yeah.
It wasn't just seen as construction. It was a miracle wrought by shepherd's art, a humble turban, a guiding heart. And now trains glide where none dared dream. They literally achieved the impossible by adopting this incredibly elegant, locally sourced solution.
So let's bring it back to you, the listener, whether you're a learner, a manager, a problem solver. What does this all mean for you?
I think it's just a powerful reminder that the most robust, the most effective solutions often blend that high-level planning, the steel, the steam, the budgets, with really low-level, deeply localized observation, like noticing the fold in a piece of cloth.
Yeah, absolutely.
Think about it. If that chief engineer had just dismissed the shepherd, because he didn't have a fancy title or a degree,
Right.
that whole railway project might have just been abandoned permanently.
It's true. Critical thinking isn't only about vetting the data you have, it's also about vetting the source of potential data with impartiality. Don't dismiss something just because it looks humble. The solution to what was probably a multi-million-pound failure was found in something as simple as how a local guy dressed himself.
It's a perfect lesson in critical humility, isn't it? And valuing those non-traditional sources of expertise. So we started with this insurmountable Watawala railway challenge. We saw the complete failure of traditional engineering methods to solve that gradient problem. And then we found this elegant, high-density solution inspired by the visual geometry of a simple shepherd's turban. A simple twist, as the ballad says, literally showed them how. It perfectly translated physics into practical application.
And the ballad's final lines, they really leave us with the most provocative thought, I think. It concludes with praise, right? All hail the man, so poor, so wise. Yet the crucial point is, the shepherd remains unknown by name. His insight saved this massive project, defined its structure, but he's still just this anonymous figure of local wisdom. So the question to mull over is, how many critical, elegant solutions might exist today right now in your field, whether it's manufacturing, logistics, coding, architecture? Solutions known only by the local practitioners, the people on the ground who apply them every single day. Are they just waiting for an expert to pause, observe, and notice the unique, ingenious fold in their daily routine, or the clever way they handle their tools or materials?
That's a powerful thought.
Maybe the greatest breakthroughs aren't hiding in the next big grant proposal, but in just carefully observing the humble expert working right next to you. Definitely something for all of us to mull over as we look for solutions this week.